Good morning, good afternoon, good evening. Thank you for being here, and it's a pleasure to be with you. My name is Tim Hatt. I'm the head of research at GSMA Intelligence, and I'm joined by Emanuel Kolta, a senior analyst in our team, to present some of the key findings from some recent research we've conducted in partnership with ZTE on network energy efficiencies as we head into the 5G era. We'll also be joined by Jason Tu from ZTE to comment on some of the technical innovations that ZTE is pursuing in this area. And what we wanted to do today was review some of the salient points that we have come out with in research that's being published this week. As I mentioned at the top, our objective with this research is really to set the context for why the industry is making such a push around energy efficiency, both from external factors and from factors born right out of the telecom operating environment. But then to look at the types of innovation that are taking place through different parts of the network and how we think about the implications for what a network looks like, the energy used to power it, and how that culture shifts into the wider telco business model in general. So I'll hand it over to Emanuel to run through some of how we think about the technologies and implementation being brought in.
Thank you very much, Tim. This is Emanuel Kolta here. In the next few minutes, I would like to quickly go through on innovation around energy efficiency in mobile networks and how do we define energy efficiency. I think that's the first point which is good to clear out, and I believe the cornerstone metric to measure energy efficiency is basically how many kilowatt hour energy do we need to transfer one unit of data. So kilowatt hour per GB, for example, it's a great metric to show. And in general, to speak about energy efficiency in the network, it's a huge topic, and we see a wide range of innovation around network energy efficiency. So I would like to show here what we just call end-to-end energy efficiency. So since the mobile network receive the electricity from the grid and then send the signal to the user equipment, we can define energy efficiency for 4 different categories, and one of them is sourcing. So we can try to buy energy in off-peak times and basically save the critical peak hours. We can also convert this energy in a more efficient way, so we don't lose that much during this conversion. We can speak about the transportation of the energy, and there is a significant cable loss, so we can increase the voltage and try to decrease this cable loss. And also, and probably the most important category, is how do we consume the energy itself. So we can more efficient equipment through the whole network, and we see a lot of innovation going through in all these 4 categories. In the next slide, we can show you basically how we can interpret energy efficiency in different levels. So here there is 4 main levels, and one of them is energy efficiency in the user equipment. How can we extend the battery life? This is not in the scope of this research, so we keep this one for the device experts. For us, the 3 most important part is equipment level in the RAN, site level energy efficiency, and network level energy. Equipment level is when we're talking about one active antenna or one baseband unit, and we try to improve and try to optimize these different equipments to go to sleep mode, shut down actually when they are not used, and save energy during these times. We're talking about site level energy efficiency. This is a bit more complex, and this basically we're talking about one site. So we can optimize, we can harmonize the activity in one site. So we can actually shut down the whole site. We can talk about battery solutions. So we're using different wireless technologies in one side, and we can use more advanced batteries with longer lifetime. And these batteries are essential for not just for the backup, but you can actually buy an energy on those times when it's actually cheaper and efficient. And the biggest category is the network level energy efficient. Here, I think we can split this into network planning and network optimization. So how do we plan the network to be more efficient and serve more customers with even less energy? Or we can optimize and harmonize the whole network, which means that we can start to go to more advanced technologies, because 5G is theoretically more energy efficient than previous wireless technologies. But the biggest question is here that we expect that data traffic will exponentially increase in the next years. And can we show this theoretical energy efficiency of 5G and transfer more data at the same time? So I think this is it from the innovation point of view. Thank you, Tim.
Thank you, Emanuel. And I should mention that in the research we're publishing this week, you can find a lot more detail and analysis on all of this, these subjects, and I hope you'll have a chance to take a look at that. So we've talked about the context, we've talked about what is being done and in the here and now and implemented in networks across the world. I think the last part of this discussion needs to be around how does this translate into reporting and targets, and a sort of modus operandi, if you will, across the sector. The really interesting thing, as I alluded to up at the top, was that a number of companies have taken it upon themselves to really transition climate objectives and reporting and link those to energy efficiency in the networks as part of a holistic plan that is reported on to the investment community and indeed the wider world. Looking at three major groups here, Verizon, Vodafone, and Telefonica, all of which have pan-regional operations. What we're showing is how progress has taken root against the emissions targets that they have laid out for CO2 reductions. And you can see that relative to where they are aiming to get to, the progress is moving in the right direction. And a lot of that has been driven by improvements in the renewable energy market, the liquidity, longer-term trading contracts, and indeed government support for these markets as sort of viable alternatives to traditional fuels. This is something being seen across the wider economy. And we expect this type of reporting to take place in many more organizations. So this is really encouraging. I think the challenging aspect is around really how we think about the bottlenecks. And this is something that we will be looking at in detail. Data availability and tracking. This is how operators are able to track the amount of electricity in particular that's being used across the network, not just at a holistic network level, but at an individual site level in each country, and being able to run analytics on that as to how it translates into action. Partnerships with the energy sector. A lot of large energy concerns are starting to work with the telco sector. We think there's more that can be done there around the types of technologies that are implemented and how they are tracked, and again with purchasing contracts. And then finally around organizational culture, making this, taking the lead of the teams that are responsible for energy efficiency and really infusing that mentality across the wider group, which is something we are starting to see. And we think that's really important to making this a success.
Good afternoon, ladies and gentlemen. My name is Jason Tu from ZTE Corporation. Okay, as Tim has just mentioned, with the development of the human society, the requirements of the energy for the network is increased also very sharply. As we understanding, we need more and more bandwidth, not only for the human being, but also for the IoT, for everything. So it's a great challenge for the human being and also especially for the telecom industry to improve energy efficiency. That is, we can still increase the data traffic while we can save energy as well. So fortunately, the telecom industry do have some technologies which can greatly increase energy efficiency as well. So let's come to this picture. So we can see the red line is kind of a baseline, which we are using 4G MIMO as a baseline. So we can see the energy efficiency of the 4G is much better compared with of the 2G and the 3G. But we still can introduce multi-antenna for like massive MIMO technology in 5G to keep the energy efficiency increase in the next. So we can see when we introduce massive MIMO of the 5G for the 4 antenna, 8 antenna or 16 antenna, the energy efficiency or increase also very sharply. So it's also a good news and which could be commercial nowadays. So we still have some other technology. For we understand the data traffic is very big at the day-night, but on the midnight is very small. So I mean, the base station do not need to power always at the full capacity. So it could be slowed down. I mean, power down at times, which is we do not need some bandwidth in the midnight. So we can see in the picture on the blue line is a real data traffic of some base station, and by introduced artificial intelligence, we have a red line which can forecast the traffic based on the big data. So by this kind of engine, so we can have accurate forecast for the base station and also have accurate adjustment of the power of the base station. Okay, so let's come to C. Of course, without artificial intelligence, so we can set up timer to shut down the base station and set up timer on the morning to power on as well. It's stupid ideas. But with the accurate forecast of the data traffic with artificial intelligence, so we can have a dynamic policy to speed up the power, I mean, to support more traffic, or speed down the power to decrease traffic. So you can see without artificial intelligence, the energy saving duration is about 4 or 5 hours, but with is almost 9 hours as well. So we can see much more energy. So this is some data we get from some commercial network. So we can see with the introduced energy saving policy based on artificial intelligence, energy saving is compared to the legacy way to stupid idea. So we can saving about 1,500% to 20% as well. So on the other hand, we can also introduce a special mechanism for the battery policy. For example, we are using a smart peak shaving policy. We understand when we introduce 5G to the same base station, which is already have a 2G, 3G, 4G as well, we need expansion our grid power capacity, but most of the time we have a limitation, and also we need money and a cost for this one. And by introduce this smart peak sharing policy, so we can charge for the battery on the at night, on the day night, if we need more power, which is up to the grid capacity, the battery could be discharged. So we do not need, even we introduce more power equipment for 5G, sometimes we do not need to expandation our grid capacity. And also we have a smart shifting policy. We understand the electricity price is very high on the daylight, but it's cheaper on the midnight. So we can also charge the battery and at night and discharge on the day-night to save money and also save energy as well.
So I just want to wrap up at that point and say thank you very much for your attention. We will seek to promote this work far and wide because it is such an important topic. But thank you very much for your time and have a great day.
Thank you.